Oh, I'm having fun. I'm told this is a picture of our next speaker's travels in life. Cathy is not only an exit routing person, having been at AtHome and Merit NSFNet and a whole bunch of other cool places, but she's also just completed an across-the-country bike trip. I think that's better than anything else, especially for us desk jockeys. Anyway, I'd like to introduce Cathy Wittbrodt, and she's going to go ahead and start the first talk.
Hi. Wow, it's shaking up here like I feel like I'm in California. So I wasn't really thrilled to be at 9 a.m. on Tuesday morning, but actually this is pretty exciting because as a one-time groupie of Frank Allison and the Odd Sox, being the warm-up band for Dave Katz is a really big deal. So, so anyway, for those of you who don't know, Sue Hares and I used to be his biggest fans, and we used to stand in front and jump up and down and scream Dave when he played. So. And he would blush. So I did bicycle across the country, and I have some cheesy photos, and mostly because I learned a few things across the country that actually apply to networking in a really twisted way. So anyway, I saw lots of interesting things. I've been to Fred, Texas, which is a mecca. I missed Mossy Head, Florida, because we had tornadoes that day. I've seen the exciting Hope Baptist Church. We're not really sure why it was exciting, but we took a picture. It is me with my fuzzy cat ears. Anyway, but one of the things I learned across the country is that, you know, in theory, everybody who builds networks knows that there's this fiber that goes across the country, but actually for many hundreds of miles, I rode right alongside of it. And I saw the little signs, and I learned that there are many uses for those junction facilities that you dispatch people to that don't have anything to do with networking. So anyway, this is an alligator that we saw, and I did make it all the way to Florida. So with that, I'll actually talk about other things. It was the best of times. It was the worst of times. Anyway, so we were having a discussion, and Andrew and Curtis decided that there's a network that people could talk about because it doesn't exist anymore. And so they asked me if I would talk about it. So I'm going to talk a little bit about AtHome, and certainly there's a lot of things that happened that I wasn't involved in, and there's a lot more that could be probably gleaned from the experience, but this is just sort of a slice at it that'll fit in a half an hour. So I was there from January of 1996 until March of 2000. So we had no network, we had no cable modems. It was a pretty interesting time. And it's also could be titled My Years Without Sleep. So we all have them. So anyway, so what I want to talk about is some of the things that happened when we rolled out the network. The important thing is what it isn't is a discussion of why AtHome went out of business. I wasn't there. The merits of AtHome buying Excite, what Milo's really like, because we could talk about that offline, but we're not going to talk about it here, and anything about really cable company politics. The thing you will note is that the slides that are on the web, although they remotely resemble the slides you're going to see, there are things that have been changed, and I tried to change the font so that you could pick them out as we go along. I am. Will that be interesting to you? Okay. So first I thought I stole some original slides of what the network was supposed to look like. And what AtHome was it was an organization that decided that, for better or for worse, that maybe the cable guys didn't really know how to do IP, so maybe we could provide this service where AtHome built this network and provided this service of IP data services for cable companies. So we provided IP services for 20 some odd different cable companies in the end in a whole bunch of different countries. And so we had issues that each individual cable company might have, but the scale of them was pretty amazing because everybody had their own requirements. It included, email, net news. We configured the cable modems. We configured the cable head-end gear. I mean, it was pretty much. Well, anyway, I'll talk some more about it, but that's what AtHome was. So this is what this is what we called the cloud talk, and this is what the network, well, and for some approximation, looked like. So we had a backbone that was originally Sprint ATM service, which, well, that was fun. And eventually it became we leased fiber and, it progressed. And the regional networks, I'm going to talk some more about the different parts of the network, but the regional networks were actually built on existing cable infrastructures in different areas. I'll talk some more about that. And then the RDC was where there were multiples of these, where we provided the services like net news and email and stuff for different regions. We had different kinds of peering connections to other ISPs. We connected to the Maze. We connected to the Kicks. You gotta love the Kicks. Actually, I won't talk about it here, but the Kicks was kind of crucial there for a while. We also had an organization called At Work that sold lease line services to businesses, and I'll talk some more about that. And we had deals with different content providers, so we did lots of online content. We had this really, really neat content group that did a lot of really creative stuff. They were fondly referred to as the Arts and Crafts group. And we've informed some of our management that they might not like that. So in a regional network, and again, this is sort of how it was in theory. It wasn't always like this in practice. But basically, we had a backbone router, or multiple backbone routers that connected into the backbone. And then we had regional services, and then we also had regional routers that connected out to the cable GOOP. And we also, in the end, had aggregation routers that connected in at-work customers and other kinds of lease line services. In the regions, in the backbone, we ran OSPF. Let's see. And the regional networks were kind of cool because the cable guys actually had a lot of fiber. They had Sonnet, they had ATM. So what we did was, sometimes they gave us dark fiber handoffs. Sometimes they gave us, PVCs on their ATM. Sometimes they gave us handoffs from their Sonnet gear. So we were actually lighting these, in '96, these really long fiber runs with these little itty-bitty fiber transceivers from Israel that kind of sort of worked. And, wrapping fiber around pencils to get enough attenuation. And it was a pretty interesting time. It was a lot of fun, actually, but no sleep. Okay, so in the regional data center, there was, a switch, and we had different, our network management group. We had high availability servers that did mail and news and all that stuff. There's a lot more goop here on the slide. But basically, the theory was that if a region of the network got disconnected from the backbone, the customers could still reach the RDC and get some of their services, their mail that was queued up or whatever. And, that kind of sort of worked. There were lots of challenges. And then in a head end, this is really where the IP meets the cable stuff. So there's the CMTS, which most of you probably already know what all the scoop is, but basically it's a box that connects IP on one side and RF on the other side. And we had a lot of those. And the scale, one of the scaling problems that we had was that since we dealt with 20 different ISPs, 20 different cable providers or even more, we had an abundance of different kinds of cable head-end gear. So, the Cisco guys came in the end and they were saying, oh, well, our box does all these things. And I'm like, yeah, but I've got Motorola's and Land Cities and HPs and, so it's great that your box does all these things, but, I have, a gajillion of these other things that I have to make work too. So that made it, a little bit harder than just a cable company trying to do IP because we had to make all this equipment work. Let's see, what else was interesting about this? Oh, one of the other things that we tried to do was to keep the traffic as local as possible. So each of not every head end, but it depended on the amount of subscribers, but we did a lot of caching and proxy server stuff. and it wasn't transparent, and I'll talk some more about that in a little bit. But we tried to, the theory was that if you were doing something on net, you should be able to do it as fast as your connection will allow you, but if you're doing something to the outside world, then it depended, and I'll talk some more about that later. So some of the key points, the network had multiple layers that did different things, and again, it was to push the traffic closer to the user to try to keep it from going across the interconnects as much as possible, that sort of thing. Caching and replication was a big deal. We had one of the early Harvest guys working on some of the stuff that we did. Even though Milo used to say we had ubiquitous multicast, it was a lie. It was a great theory, but we could never manage to make it work. And I'm going to talk a little bit about quality of service in our environment because it really didn't apply. I mean, it couldn't be used because everybody has their view of what end-to-end is, and some people it's a lot smaller scope. So again, some of the things that were the original assertions were that if you had fat pipes, it wouldn't. You couldn't always just throw bandwidth at it. Why not be a little bit smarter? The network should have intelligence built in. This pretty much comes right from Milo's old talk. You need good network management, And one of the things that was always a vision and actually is a lot closer to being a reality is that you could go down to, well, in California it'd be Fry's, buy a cable modem like you buy a dial-up modem, plug it in, and get registered with some cable service and be online. And with DOCSIS, that's a lot closer to being a reality. And a lot of the folks at AtHome worked really hard to make DOCSIS a reality, which is a cable modem standard, for those of you who don't know, which was actually pretty helpful. So one of the decisions that was made that for better or for worse we lived with was this concept of using DHCP client ID. And on the surface of it, it's really elegant. You sign your subscriber up and you give them this subscriber ID, and then that ends up being in the client ID field, so you always know who they are and you can track them and la-da-da. But of course, it wasn't the best thing because not all the machines did client ID. So a lot of people, they ended up not being able to use DHCP because they couldn't use their software wouldn't allow them to have client ID. There were lots of problems with it. You couldn't readdress as easily. Like if you're just using DHCP, and everybody has a an address from the DHCP server, if you split a node and create more bandwidth, which I'll talk about in a couple minutes, it's really easy to readdress everybody. And, people figure it out pretty quickly if they statically configure that, that's a bad thing to do because then they're offline. And we saw that with some of the cable providers that we worked with. And it wasn't one of my favorite decisions. So one of my early experiences at a cable show, if you haven't been to a cable show, it's a lot like Interop, except that if you focus in, you can meet Adam West and have your picture taken with Hulk Hogan and win a herb garden from the Garden Channel. And we had our first booth, and it really wasn't actually the at-home service. It was kind of cheating. And one of the guys I work with was explaining to these people that, there's two ways to make more bandwidth. One way to make more bandwidth is to use another TV channel. So a cable service is done on channel, I don't know, the equivalent of, channel 5 or whatever. Not really, because that's too important a channel, but it uses a 6 megahertz TV channel. So the other way you can do it is you can split up nodes. And one of the guys that was working at our booth said, and we were surrounded by the equestrian channel, the garden channel, Fit TV, which they did aerobics every 5 minutes. And he said, and if you look around here, you can see several channels that could be, shall we say, reallocated. So anyway, that was one of my early, that sticks in my mind of how to make more bandwidth, because once you go to the cable show, you think, wow, who buys these stations? So when you split nodes, you have to readdress, and addressing was always the bane of my existence, so you're going to probably hear more about it than you care to. Let's see. Oh, and the other thing is if you make more bandwidth using more TV channels, then you can't have, the equestrian channel and, Fit TV and Hulk Hogan's Adventures or whatever, so you might lose revenue. So we had an interesting cultural clash of IP people meeting cable people. And some of them were really clueful with IP. And of course, we knew nothing about cable. So, I can't really say that, there was a lot of clue on both sides. But the interesting thing about cable companies in the US at the time was that they were all these little mom and pop companies that got bought by these big companies. So there was like corporate, right? And then there were all these little independently run little regional things. So some of them were just really amazing. Like the guys in the Bay Area in one of the markets were just, they taught us about fiber. We taught them about routing. I mean, it was just wonderful. And then there was, Joe in, the middle of nowhere who it's like, you got what? So it was a really interesting, and then there was corporate saying, we're doing this at-home thing. So there was a lot of interesting interactions. And to them, CMTS gear, good CMTS gear did RF well because that was their thing. Cable was their thing. So, they didn't want anything to mess up their cable, just like we didn't want anything to mess up our OSPF. So it was an interesting time. So I have to tell a couple of these stories because I can't help myself. So I was in the Sunnyvale head end one day, and there was a man explaining to our server guy, there was a man who brought the CMTS there explaining to the server guy, hey, I know it doesn't work, but if you just point default at my CMTS, it'll work. And, I was pulling cable and trying to ignore the whole thing, but I couldn't help myself. So I went around the corner and I was explaining to the man that I could point default at him, but then the world got really small because my router was the way out and his wasn't. So, so we had this long discussion where he informed me that I really didn't know how to hook to the internet and that I should talk to his guy at UUNet because clearly I didn't know what I was talking about. So I told him to just humor me and configure it, and later that day I found out that he was the guy who wrote the routing software in the CMTS. So I was a little afraid. And so the early CMTS was, well, challenged. We had a couple different vendors, and even when they said they were a router, well, that was a little bit of a stretch. Some of them were bridges, which had their own problems. They certainly didn't really understand CIDR, which I'll tell you about in a little bit. And they didn't really understand why RIP v1 really wasn't, well, some kind of combination of RIP v1 and a little bit of v2 really wasn't routing. And we learned a lot about why you need filters in the modems when we started hooking up customers, because people could actually print to their neighbor's printer and stuff, which was pretty cool. It made for a lot of harmonious living environments. And now, I went to the security thing last night and I was thinking, oh my God, what are they doing now? Because, they were just doing harmless, accidental things back then. Now it's got to be really scary. So the original equipment we had, no big secret, Motorola and Land City. And I'm sure that, to be real honest, all this equipment has changed a lot since 1996. So, but it sort of had RIP v1 on the Motorola's. And the only subnet it recognized was a /24. And you could put 20 /24s on a CMTS, so not 32, not 16, not 8, but 20, which, was really fun. The land cities were bridges, and so, you had to be really careful what you did on your Ethernet. And then later there were others, and like I said, DOCSIS was certainly a breath of fresh air. I mean, nothing's perfect, but boy, it was a lot better. And the key thing to remember about AtHome was that AtHome didn't pick the CMTS, the cable guys did. So, we had a certification process where we said, here's the ones that cross the bar. Sometimes they barely cross the bar, but we didn't pick them. So we ended up with a lot of interesting equipment. So, so the first at-home deployment came, and for those of you who don't know, I collect quotes, so nobody's safe from being quoted. So one of our early beta customers was never satisfied, thanks Tony, and he said he only got 800K, and at the time, 800K was pretty awesome. But he does say that 250, and his opinion will buy you a double latte. So, anyway, the other. Oh, I have 10 minutes. Oh my God. So one of the early things that happened was that we'd hook somebody up. Cable guy would go out, hook them up. Then the next guy would go out and say, "Oh, that's noise," and filter them. So, so that was fun. I guess I'll speed up. We had a guy who plugged an ISDN cable, an ISDN modem into the LAN and proxy ARPed for everybody, which was pretty cool. And this was what our first customer actually said. And you know, you can't make this stuff up. You just can't. So anyway, so needless to say, we got 24/14, not 24/8. But thanks to Sean Duran, who would only listen to 24/8 announcements, it depended on what day, whether you could get to Sprint or not, whether you were the lucky one that they believed, which was pretty cool. We had probably 6 or 7 trouble tickets a day, sometimes more, of routers that didn't have IP classless turned on. And we had no mechanism to get more, which was pretty scary. Lots of people thought Net 10 was infinite, and since all the cable modems were out of Net 10, that was kind of a drag because they just didn't get it. They wanted us to go get more RFC 1918 space. We had this back office system that had to integrate everything from everybody else's back office systems. So that was pretty tough, and nobody ever got all the functionality they wanted because they all had their systems, and everything was a 2-year integration process, which was kind of a drag. Open access provided other challenges, and I think it still does. I'm on the Aaron Address Council or Advisory Council, and we're still dealing with, what do you do for address space? But basically, it's hooking more than one ISP to a cable head end or to the cable infrastructure. It was, for us, we were kind of schizophrenic because we had to supply it in Canada because it was mandated, but we were fighting it in the US because nobody wanted it. So it was kind of hard to solve it and not solve it all at the same time. I think the key thing that's still happening right now, the takeaway from this would be that multiple organizations are applying for address space for the same exact known number of homes. So there might be 500 homes, and there's 5 ISPs that are going to Aaron and saying, I need address space for these 500 homes, which, so you could easily over-assign. And then there's a lot of routing issues with that, but since I don't have enough time, we'll skip it. Now about network management. The thing that I think should happen with CMTS is that I think that there should be a way for the cable guys to manage for one group to manage the RF part and another group to manage the IP part, and all the access schemes to the routers at the time were different access levels, but they didn't tease apart the different functionality. So we had a lot of issues with who's going to manage the routers. Are they going to be in the routing system? Are they going to run, God forbid if they do OSPF, how they're going to do it, and are they going to run it? So we static routed to all the CMTS because, we just couldn't, they ran different protocols. We didn't know how they worked. We didn't, we had multiple groups, multiple organizations managing them. Let's see. We had a lot of problems because of that with OSPF externals because all the static routes became externals. And the NOC decided that the way to solve every problem was to redistribute connected, which means that every interface subnet becomes an external, even if you don't need it to. And for those of you who haven't, make sure you keep the number of externals down in your OSPF. That's all I can say. It's just really ugly. Another issue we had was it was all you can eat for $39.95, and people weren't using the proxies. They were bypassing them. Lots of things weren't cacheable, as you'll see from yet another quote. So we had a lot of issues, and they sucked down a lot more than they sent. So all of the QoS mechanisms didn't really work for us. I mean, how do you distinguish 2 million subscribers from the NAP? And say, oh, this guy gets this much into him and that guy gets that much. So we had a lot of those kinds of issues. So I came here and presented this thing about Cisco's committed access rate because that was one of the really great ideas for solving the problem. And we did a lot of work on that and found that, of course, that wouldn't be useful. Most of the QoS mechanisms aren't really end-to-end, and they didn't really help our problems. So it was really hard to sell different levels of service unless you limited at the cable modem, which meant that the on-net, as fast as you can, off-net, slower thing never really worked. We just ended up having to limit at the cable modem. I love this. AtHome isn't changing the world. We're just facilitating existing devices. We had lots of problems with open relays, people misconfiguring their software, people exploiting that. That's no big surprise. Somebody posted their personal 900 number and decided Cathy@home.net was a really great return address, so I got really interesting email from around the globe. We had a live sex cam in Sunnyvale. We had people playing video games that really liked the fact that they could kill the dial-up guys before the dial-up guys saw them. We had a lot of kids, like the son of one of the big cable providers owners made somebody mad in a chat room, and then the denial of service attack took out, half of the backbone before we found it. So it was a joy, and it grew every day because we were hooking up so many subscribers. So this was a quote from the guy who did a lot of the product planning for @Work. It actually made our traffic more symmetrical. So the cable guys were sucking, the cable subscribers were sucking stuff down. The @Work customers had traffic the other way, which helped a lot with peering. We did really well just because for a while the customer service was good and people were so unhappy with the big guys that they bought from @Work, which was kind of cool. So in the end, I think that one of the big problems that we had was just the scale of trying to do what we were trying to do for as many cable providers as we were trying to do it, at least from my perspective. That, God knows there were certainly a lot of other hurdles, but everybody had requirements, everybody had back office systems, everybody had, some weird thing that they wanted to do on their cable plan or peer over a cable modem with some ISP, and, and it was just hard for, a smaller group. I mean, it was still pretty big in the end, but it was hard to make everybody happy. And so again, we had a lot of problems with OSPF scaling and externals. We had a lot of problems with peering bandwidth, endless problems. We had, 1% of our users used 90% of the bandwidth. And the minute you did something to them, another 1% of the users came up and started using. And, it's hard at $39.95 a pop to deal with that. Lots of interesting regional peering. Like I said, people who wanted to peer with you over a cable modem in their son's garage. And sometimes it was tempting. And just to conclude, our group found that that when you have as little sleep as we had for as long as we had, that you have to keep your sense of humor. And one of the guys in my group who helped with this presentation found the list. We called it the "Why Don't We Just" list. Just like, why don't we just tell Aaron we're good guys and get a /8? So just to give you guys a little humor for the day, why don't we just reboot it and see what happens? Why don't we just redistribute full internet routes into OSPF? And you laugh, but Milo really wanted to do this, and so we all agreed early on that we had the passwords and he didn't, and if we all stuck together, we could just tell him we did it, even though we didn't. Why don't we just put all of @Work's T1s into area 0 so we'll know when they flop? Why don't we just hook them together and see what breaks? And this was actually what someone suggested when we bought Excite. Why don't we just plug our networks together and see what breaks? Lovely. And this is one of my favorites. Why don't we just augment our backbone connection to the local POP with a load-balanced cable modem link? And I think that's all I have.